How much can landing in snow protect you from a fall? Well, we've seen it save people who jumped off a roof or dived off a cliff. And yes, even who fell from the top of a mountain. But what about a fall from even higher up? Like from an airplane? How much snow would be required to break that kind of fall? What kind of snow would be the best to fall into? And how should you position your body for a safe landing? This is What If, and here's what would happen if you fell from an airplane into snow. Okay, What Ifers, if you're planning on jumping out of an airplane without a parachute, you might want to check out our video on what happens if you die, because that's what you'd have to look forward to. The math changes depending on how much you weigh, but let's imagine that you weigh 65 kilograms. As you fall from an airplane that's thousands of meters in the air, your body would travel at a velocity of 55 meters per second. And when you smash into the solid ground below, that velocity would instantly drop to 0 meters per second, causing catastrophic injuries. But if there was a whole bunch of snow on top of that solid ground, it might be enough to save you from dying. Don't believe me? Well, it's happened before. In 1972, a Serbian flight attendant named Vesna Vulovic survived the mid-air explosion of a jetliner after plummeting hundreds of meters through some trees and landing on a snowy hill. Yeah, she broke her legs, pelvis, some vertebrae, and fractured her skull, but if a little snow could save her life, then why not yours? But let's not get too confident here, because there are still a ton of ways that this could go completely wrong. If you're going to survive, you'll need a bunch of factors to line up perfectly. The key to surviving a fall from an airplane is to make your deceleration last as long as possible. Okay, math again. If you weigh 65 kilograms and fall 6 kilometers, you'd be heading down to Earth at a velocity of 55 meters per second. If you land on solid ground and you only decelerate for half a second, you'll hit with a force of 7.1 kilonewtons. If you're not a math teacher or a scientist, that's 726 kilograms. But if you were able to stretch that deceleration out by even the smallest of amounts, it could make a world of difference. For example, even stretching the deceleration time out to 1 second would reduce the force to 356 kilograms. And if you decelerate for 2 seconds, it would be 183 kilograms. Landing in a nice bed of snow could definitely help you slow down enough to save you. But it would have to be the right type of snow. The snow would need to be able to compress, slowing your fall to less than 98 meters per second squared. So the snow must be thick enough for this to occur. About 80 meters. The reason why you need to travel at less than 98 meters per second squared is that this is 10 times the force of gravity, the approximate acceleration that humans can make without too much damage. So, considering all this, you'd better cross your fingers that you'll be landing in lots of soft, fresh snow. Because of its lower density, fresh, dry snow can be compressed more and soften your landing. Packed snow and wet snow are denser than fresh and dry snow, so they can't be compacted as much and wouldn't extend your deceleration enough to save you. But even if you're 100% sure that the snow you're landing in is fresh, deep, and dry, you're still not out of the danger zone. To give yourself the best chance at survival, you're going to want to land in a belly flop. That may seem strange, but it would actually be the safest choice. You see, if you land feet first, all of your weight will press down on that small area. But if you land on your belly, your weight will be more evenly distributed, so you won't be hurt as badly. Now, if by some chance you happen to survive the landing without too many injuries, you're going to have to dig your way out of the snow. As you can imagine, falling all the way down from an airplane would be pretty disorienting, so your first step for getting out of the snow would be to figure out which way is up. One helpful trick that I always use is to drool a little and see which direction it slides down your face. The opposite of that is upwards. Of course, this is all easier said than done. In reality, there's a reason we've only heard of one person who's ever survived falling out of a plane. Because it's very unlikely to happen.
So cold!
It's about to get a little chilly in here. What's the coldest you've ever been?
It's actually so cold!
Well, today, we're cranking that down a notch. Today, you're heading into absolute zero territory. Is absolute zero really colder than outer space? What could we do with such a low temperature? And how badly is this going to hurt? This is What If, and here's what would happen if you touched absolute zero. So besides sounding like an awesome band name, absolute zero is the lowest possible temperature in the universe. At minus 273.15 degrees, it literally can't get any colder. It's so cold at absolute zero that the very atoms have stopped moving. That's really cold. Even the freezing vacuum of space is only minus 270.41 degrees. So absolute zero is colder than the dark reaches of outer space. And today, you get to be our guinea pig and touch something cooled down to absolute zero. I know, right? What an amazing opportunity. Now, let's say we froze a small piece of metal down to absolute zero temperature. Would you mind picking that up for us? As you pick up the piece of metal, you'll find that it's absorbing all the heat from your hand. Your hand is covered in moisture, which is being robbed of all its heat. And it begins to freeze once the temperature drops below zero. Okay, you can let go of the metal now. Oh, you can? Well, that's because the water freezes inside the tiny pores of your hand and the surface irregularities of the object, so you'll get stuck. Think of it like when you lick a flagpole in winter, but a lot more painful. And if you try to remove the piece of metal, the flesh of your hand will rip off with it.
No! Kelly Clarkson!
Just remember, you volunteered for this. Next, blood vessels near your skin will begin to constrict. This will reduce the blood flow to the affected areas and help keep your vital organs alive. It's like your body puts up a roadblock. The problem is, this lack of blood supply and oxygen to your skin can cause damage to your cells. At absolute zero, the piece of metal will lower your cells' temperature until they are so cold that the liquid inside them freezes. This would create sharp ice crystals and damage the structure of your skin cells. And brace yourself, it gets worse. You can expect even more damage to the lower layer of your skin, aka the dermis. Not to mention all the damage to your hand's muscles and tendons. Okay, maybe we should call it quits on this. Well, because you were such a go-getter, you decided to hold on to the absolute zero metal as long as you could, and as a result, you've got 4th degree cryogenic burns on your hand. This will eventually lead to gangrene and extensive necrosis. Do not Google that, trust me. With your injuries, there's only one way to save you: amputation. So, besides maiming you, what could we actually do with absolute zero? Well, hopefully, the study of absolute zero temperature will lead to discoveries in cryogenic research. The field of cryonics seeks to preserve whole human bodies at ultra-low temperatures, around minus 196 degrees. Yeah, that's not as cold as absolute zero, but if we can get a handle on how to work with such a low temperature, we can use this knowledge to prevent your body from crystallizing and your vital organs from being destroyed after you're frozen. Absolute zero is the lowest possible temperature in the universe. Nothing gets colder than that. So, if the entire Earth suddenly cooled down to the most frigid temperature for even 5 seconds, it would wreak a lot of havoc. Just how cold is absolute zero? What would happen to your body at this temperature? And what's the coolest thing about it? This is What If, and here's what would happen if the Earth dropped to absolute zero for 5 seconds. Temperature is how we measure kinetic energy of the particles in any object. Yeah, it tells us how fast atoms, molecules, and particles move. The hotter a gas, liquid, or solid gets, the faster the particles move. And when that movement slows down, the colder that substance becomes. At the lowest temperature possible, or absolute zero, particles stop moving altogether. This is because at 0 Kelvin, or minus 273.15 degrees Celsius, no heat energy remains. The coldest ground temperature ever on Earth, 184 Kelvin, or minus 89.2 degrees Celsius, was recorded in Antarctica in 1983, but it doesn't even come close to absolute zero. Even the coldest known place in the entire universe, the Boomerang Nebula, 5,000 light years away from Earth, is just a tad warmer at 1 Kelvin. So, are you ready for the coldest 5 seconds ever? At room temperature, that comfortable range of temperatures of about 293 Kelvin, the air molecules move at an average speed of 1,800 kilometers per hour. As the temperatures on Earth suddenly plummeted, all those particles would slow down. At 0.00001 Kelvin, the atomic particles would be moving at a speed of about 0.18 kilometers per hour. That's 1,000 times slower than their speed at room temperature. Getting this close to absolute zero, all chemical reactions would be closer and closer to coming to a complete stop. And this would be very bad news for you and everything else on Earth. Chemical reactions are responsible for everything, including how your brain communicates with your body. Without the trillions of chemical reactions going on inside of you, you wouldn't be able to breathe or turn food into fuel. Temperatures near absolute zero would be devastatingly cold. Even at a comparatively toasty 77 Kelvin, you'd be in serious trouble. That's the temperature of liquid nitrogen. After just a few seconds of exposure to this temperature, you'd suffer severe burns, blistering, and frostbite. Needing a toe or 10 amputated could be a definite possibility. So, just 5 seconds of absolute zero could do incredible amounts of damage to all life forms on Earth. But I have good news. The chemical reactions wouldn't come to a total standstill. Even at the near absolute zero temperature of the Boomerang Nebula, chemical reactions do still appear to take place. This is thanks to the strange effects of quantum physics. And Whenever quantum physics is involved, things get weird. With all the atoms on Earth at a near standstill, you'd find them starting to clump together. They'd be forming a state of matter known as a Bose-Einstein condensate. This would mean that every atom is in the same energy state and essentially identical to one another from a physical point of view. They'd start to behave as a single atom. And if you could become a Bose-Einstein condensate, it would be pretty cool, pardon the pun. For those brief 5 seconds, you'd have some unique physical properties, like superfluidity. Yeah, you'd be able to flow through tiny cracks without any friction. Only there wouldn't be any cracks because you wouldn't be the only superfluid thing on the planet. But there is a catch. Bose-Einstein condensates can only be formed when bosons are cooled to near absolute zero. Bosons are all atoms with an even number of electrons. That means only some of the atoms in your body and the environment around you could become a Bose-Einstein condensate. And lucky for you, reaching a temperature of absolute zero wouldn't be possible. If Earth and everything on it plummeted to absolute zero, it would instantly pull the heat from the space around it. To keep you and the planet at 0 degrees Kelvin, even for 5 seconds, you'd need an infinite amount of resources. This makes it mathematically impossible. But that wouldn't mean that 5 seconds of near absolute zero temperatures wouldn't destroy just about everything. And nothing would ever come back together from this soup of atoms that you and the entire planet would turn into. Earth has gone through at least 5 major ice ages in its history. And you better start adapting now, because another ice age is about to begin. Hypothetically. How would a new ice age change Earth as we know it? What could you do to survive on a frozen planet? And how are we already delaying another ice age? This is What If, and here's what would happen if we entered a new ice age. During all ice ages in Earth's history, global temperatures dropped well below freezing across the planet. And it wasn't just a few icy trips around the sun. Earth can take hundreds of millions of years to thaw out. The most recent ice age started the Quaternary period around 2.6 million years ago, and technically, we're still in it today. Ice ages have the power to radically change our planet. They reshape landscapes, they create new lakes and rivers, plants and animals cling to life, either adapting or facing extinction. So, if a new ice age began today, how soon would our civilization collapse into chilly chaos? Our 6th major ice age would be a few thousand years in the making, and it would begin with Earth's tilt on its axis going through its cycle of changes. An unstable tilt plus a little wobble in our orbit around the sun, and there would be less and less solar radiation reaching the planet. You'd see the first effects of this on the northern hemisphere. Each year, the once lovely summer temperatures would start to drop. Eventually, they'd fail to rise above freezing. And that's when the snowfall would begin to build up. Over time, that snow would compress into ice sheets. These glaciers would start in places like the northernmost regions of Canada, Scandinavia, and Russia, and they would spread from there. The ice would mostly form on dry land. That's because the water surrounding the ice would create a barrier preventing it from expanding as easily. Today, about 10% of Earth's land surface is covered by ice. As our new ice age progresses, you could see that go up to about 25%. Ice would cover Eurasia from the British Isles to Siberia. Himalayan ice sheets would expand through Asia, and while the southern hemisphere wouldn't be as icy, an ice sheet would run from the southern tip of Patagonia well into the Andes Mountains. But ice wouldn't be the only change. Sea levels could drop around 120 meters lower than they are right now. This could close off the Mediterranean Sea to the Atlantic Ocean. Without anywhere else to go, rainfall and glacial melting would feed bodies of water in regions that aren't frozen over. Some rivers would also change their usual runoffs and form new lakes. With all these changes in sea levels around the world, land bridges would re-emerge. Russia would now be connected to Alaska, and the islands of Indonesia would connect to mainland Southeast Asia. The borders would change and bring many countries closer together. Or it would result in whole new countries being formed, opening up new land for you to migrate to. And you'd need to. Regions that you and hundreds of millions of other people used to call home would be essentially uninhabitable. Surviving the cold would mean moving away from the iciest parts of North America and Eurasia. But the rest of the world wouldn't be too welcoming either. It would get really dry. Deserts and tundras would expand, so the remaining tropical forests near the equator would be refuge for much of the planet's plant and animal life. But what about us? Well, during the most recent ice age, we actually developed as a species. The land bridges allowed us to spread out across the globe, and the climate forced us to adapt with new tools and clothing. And as Earth rewarmed, we started farming. It's likely that we wouldn't fare as well with a new ice age. Not right away, at least. Almost all of our agricultural land would be lost. So intense overcrowding in hospitable regions would create chaos and unrest. You should get ready for extreme competition for life's basic necessities. But I do have good news to ease your worries about this frigid doomsday scenario.
Come on! Bring it!
Well, sort of. Based on current climate science and the amount of carbon dioxide in our atmosphere, we may have postponed the next possible ice age by about 500,000 years. And if we keep pumping out greenhouse gases, it's possible that we've not only postponed it, but we've made it impossible. That just means we'll all overheat, which I guess is better than being frozen. How much water would you need to extinguish the sun? How would we deliver such an enormous amount of water anyway? And would all that water even make it to the star? Wouldn't it evaporate before reaching the sun's burning flares? Whatever your plan is, be careful, because trying to put out the sun would only make it hotter. This is What If, and here's what would happen if we extinguished the sun. Before we dive into how things would go terribly wrong, let's talk about where we could, hypothetically, find all that water. I've got some ideas. How about the universe's largest ice cube? A gigantic space fire hose? Or an entire water world tossed into the sun? Okay, fine. Let's be a little more realistic. No giant ice cube will be passing our solar system anytime soon. That leaves us with one possible scenario. We'd have to sacrifice every single drop of water we have here on Earth. We would drain our oceans and deplete all the fresh water too. Then we'd build a very large fire hose and blast it at light speed towards the sun's core. And then... Wait, did I say there was just one option? I forgot about the possibility of using a water world. leaving the Earth with no sun and no water seems a bit unreasonable. And we could avoid that ocean draining scenario if we found a way to throw an exoplanet into the sun. But not just any exoplanet. We'd be aiming for a real-life water world. And we just happen to know where to find it. Some 40 light-years from Earth, there's a planet primarily made of water with an atmosphere of steam. Scientists named it GJ1214b, but we'll call it the water world. This planet is 2.7 times bigger than the Earth in diameter, and it weighs 7 times more than our planet. And it has much less rock and a lot more water than the Earth does. There would probably be enough water on the water world to put out the sun forever, but it wouldn't happen the way you might expect it to. If we were able to crash that water world into the sun, the first problem would be the water freezing in space. Same thing would happen if we could pull out a gigantic fire hose with all of the Earth's water and aim it at our star. The ice would continue shooting towards the sun, but it would face mass evaporation as soon as it hit the star's atmosphere. The water vapor would then break down to its basic ingredients, oxygen and hydrogen. And that's when something interesting would happen. The sun may seem like a huge fireball, but it's not exactly on fire. Inside its blazing core, the pressure is 340 billion times more than it is on Earth's surface. This immense pressure fuses hydrogen atoms together, making helium, and giving off energy in the process. Since hydrogen acts like a fuel for our sun, pouring water on it would be like throwing gasoline on a fire. You'd see the sun turn bluish-white as it grew 6 times bigger. It would create an extreme heat wave across our planet, but at least we wouldn't be engulfed by the expanding sun, although there could be other consequences. We wouldn't be able to put out the sun with its own fuel, but if we fired enough water at it at the speed of light, it could break up the sun. The pressure inside it would drop, the hydrogen couldn't fuse together into helium, and that would shut the sun down. But with no sun to give us warmth and light, the Earth would turn into a frozen world. After just 1 year, Earth's temperature would drop below -73 degrees. Most of the plants and animals would be dead long before that. And what about us humans? Well, in the deepest parts of the oceans, geothermal vents could have kept us warm and supplied us with energy. But we just poured all of Earth's water into the sun, dooming ourselves to freeze. Lucky for us, the only thing in the universe that can do any substantial harm to the sun is the sun itself. And that would take billions of years to happen.
What if the sun disappeared right now? Would you be able to handle eternal darkness? Cold temperatures? How about flying off into space? The sun is the only star in our solar system, and it gives life to everything here on Earth. Would we even be alive if it vanished? This is What If, and here's what would happen if the sun disappeared. The truth is, we wouldn't even notice for the first 8.5 minutes. This is how long it takes sunlight to travel to our planet. So even if the sun disappeared, its last ray of light would take 510 seconds to reach your skin. And what about gravity? The sun is the dominant gravitational force in our solar system. It has all 8 planets moving around it. So if the sun disappeared, would we fly off into space? Yes, but not right away. The force of gravity turns out to have speed too. In his theory of general relativity, Einstein proved that gravity is just as fast as light, and not instantaneous as was previously thought. This means the Earth would still be orbiting a recently vanished star with no clue of the upcoming darkness. But just for 8.5 minutes. When the last of the sun's rays reach the Earth, eternal night wouldn't be our only problem. The very same moment the sun disappeared from the sky, Earth would start traveling into space at 18 miles per second. Assuming the Earth didn't collide with any other planets or asteroids, or get sucked into a black hole, it would be moving in a straight line for 43,000 years before it found another star to orbit. But you wouldn't have to worry about that. Within 2 seconds, the moon would go dark, since there would be no sunlight to reflect. But the stars would still shine, and your electricity would still work. unless it's powered by solar panels. However, gravity and illumination aren't the only things we rely on the sun for. Plants need the sun for photosynthesis. Turning light into energy is how plants stay alive. Without sunlight, most small plants would be dead within days. Larger ones, like trees, would survive for several decades due to their slow metabolism. This would knock out the bottom tier of the food chain. Most animals would die off slowly. Only scavengers feeding on the dead would remain until they froze to death. Because within a week, the average temperature on Earth would drop to a bone-chilling 32 degrees Fahrenheit. And by the end of the first year, minus 150 degrees would be the new norm. And it would keep dropping until stabilizing at minus 400 degrees Fahrenheit. The oceans would grow colder too, but just on the surface. Thanks to geothermal vents, they would remain liquid underneath, despite being buried under a thick layer of ice. So if you're lucky enough to survive, consider moving to the ocean floor. In the end, the organisms living around those geothermal vents would be the only living beings not to notice any difference. They don't need the sun to live and could continue to thrive for billions of years until the planet became a frozen chunk of rock drifting in space.
Have you ever met someone who always feels cold, even when everyone else is warm? We tend to joke that these people are cold-blooded, but do we even know what that means? Having cold blood involves more than just needing a few more blankets than everyone else. If we all suddenly became cold-blooded instead of warm, our lives would be completely different. Why would we need to eat less food? Could we only survive in warm climates? And how might our cold blood help with space exploration? This is What If. And here's what would happen if humans became cold-blooded. When our body temperatures get too hot or too cold, we have built-in processes like shivering and sweating to help regulate them. But cold-blooded or ectothermic creatures don't have that same luxury. That means that if we became cold-blooded, our lives would be a lot more limited. And in the winter, a good heater could be the difference between life or death. Do you think we'd be able to survive? If you were to wake up tomorrow with cold blood, there'll be a lot of new things to get used to, some good and some bad. For one thing, your grocery bill would be a lot smaller, as you wouldn't have to eat nearly as much as you do now. Warm-blooded animals eat a lot because they need all that energy to keep their bodies at the right temperature. But what if you like your 3 meals a day? Sure, you could keep eating as much as you like, but with no use for all those calories, all that food would go straight to fat. If you're smart about it, you probably wouldn't have to worry about visiting the doctor as much anymore either. Our warm-blooded bodies provide a nice constant temperature for germs to breed in, as opposed to the variable temperatures of the cold-blooded. If bacteria and viruses can't get used to your body's climate, then your chances of getting sick drop significantly. But that's not to say that you'd be invincible. If you don't make a conscious effort to keep yourself warm, your low body temperature could slow down your immune system, allowing bacteria and viruses to creep up and infect you. So, you may have become a less desirable host for these pathogens, but now you also have an active responsibility in fighting them off. Keeping yourself at a proper body temperature would become a crucial part of your everyday life. Since you'd be relying on external sources of heat, your house would have to be kept much warmer than you're used to. Your thermostat would not only control the temperature of your house, it would be setting the exact temperature you want your body to be too. During the winter, any money you would have saved on groceries would be quickly gobbled up by a sky-high heating bill. Cold-blooded land dwellers tend to do best in temperatures between 21 to 40 degrees Celsius. So to make things easier for ourselves and to live more active lives, we'd all be best to move closer to the equator. Except that'd be a lot of people to move to one area of the planet. And soon, we'd be running into the usual issues that come along with large-scale human migration. It'd be overcrowded, our resources would be running out, and who knows how long it would take before political instability came into play. So maybe it'd be better if some of us just moved to another planet altogether. Yeah, it's a little ambitious, but bear with me because space travel should actually be much easier for cold-blooded humans. When cold-blooded animals hibernate over the winter, they lower their body temperatures to that of their surroundings and enter a state called torpor. In this catatonic state, their breathing and heartbeats slow down, and they can survive for long periods on stored body fat. By employing this method, a cold-blooded space crew could survive much longer than a warm-blooded one, allowing them to travel for months or even years on minimal resources. Maybe out there in space they'd find a planet that's perfectly suited for cold-blooded creatures. And maybe there are already some living there.
Oh my
What if all ice in the world acted like this? This isn't just any regular ice. This is hot ice. Now, what if we replaced all the ice we currently have in the world with this new hot ice? Could you eat it? What would happen to our ice caps? And could we live like this? Please? This is What If. And here's what would happen if ice was hot instead of cold. So, what exactly is hot ice? Well, it's simple. It's made by boiling baking soda, vinegar, and a little bit of water. From that, you get sodium acetate. It's a white powder that's used in chemical heating packs. Now, you can make sculptures and ice crystal formations. Although this substance isn't made out of ice, it definitely looks like it. Except you probably don't want to touch it as it's quite hot. So, what would happen if hot ice was everywhere? With all our ice being hot instead of freezing cold, it would significantly change a massive part of our world, the Arctic. Instead of the area being one of the coldest on Earth, it would be a lot warmer. One of the things you'll notice quickly will be all the animals migrating to new locations, because the Arctic is now far too warm for them. Although hot ice won't necessarily burn your skin right away, it would be pretty uncomfortable for the foxes and polar bears living in the Arctic. Not only would it be uncomfortable to touch, but it would also make the Arctic much warmer than before. And prolonged exposure to the hot ice wouldn't be good either. Instead of frostbite, thermal burns would occur. Remember, although we call it hot ice, it's far from frozen water that happens to be hot. This ice is a collection of chemicals and should not be played with, consumed, and definitely not lived in. So that being the case, all these Arctic animals would be moving down to Canada or wherever else they might be able to find a home. But it might not be all that bad. Our new hot ice caps in the Arctic will take longer to melt than the current ice caps we have today. It's no secret that the ice caps are melting at a rapid rate due to the Earth heating up. If you've seen our previous video, What If All Ice Melted, then you know what those consequences are, and spoiler alert, they're not very good. But with our new hot ice caps, they won't melt until they reach 58 degrees Celsius, as opposed to regular ice that melts at 0 degrees Celsius. Although they would be radiating their heat off of each other, it's unlikely that they'd make the entire Arctic a whopping 58 degrees Celsius. At that temperature, it would be nearly impossible to sustain any kind of life. The Arctic wouldn't get that hot, but it would be much warmer than what the Earth is used to. And that goes for all the ice. Instead of bundling up in the snow, we might be able to get away with wearing shorts and a t-shirt. But what if all this new hot ice did melt? Well, apart from the issues with flooding and rising ocean levels, we'd have a lot more to worry about. All this melted hot ice would become part of our oceans. Anything living there would most likely die, considering that we're now introducing billions of liters of chemicals into the sea. And what would happen if you accidentally drank some of this stuff? At first, you'd probably be okay. In small doses, hot ice isn't enough to kill you. But if it's all you drank, you'd quickly get sick and then die. And if all our ice happened to be made out of hot ice, would our oceans be made of melted hot ice? If that happened, our oceans would be filled with a supersaturated solution. And if somebody happened to have sodium acetate handy and dumped a massive amount of it into the ocean, it would slowly crystallize and solidify. This happens due to a chemical reaction when the saturated solution can't absorb any more solids. In this case, it starts to crystallize, turning the liquid into a solid. But that might be the least of our worries at this point. After all, the Earth would have to be above 58 degrees Celsius for this to happen, which would make it unlivable for us humans. We might have to move to Mars if this ever happened. Imagine Earth covered in thick sheets of ice and sea levels so low you could walk to a different continent. This is what our planet would look like during an ice age. There have been 5 of them in Earth's history, and they've had a huge impact on our present world. Now, try and imagine an Earth where these ice ages never existed in the first place. What ecosystems would change? Would humans have evolved? And why do ice ages happen? This is What If, and here's what would happen if the Ice Age never happened. Over a century ago, Milutin Milankovitch hypothesized that changes in the Earth's orbit, the angle of its axis, and the direction of its axis are what create long-term changes to the climate. Known as Milankovitch cycles, they create the seasons we know well and the ice ages that we're glad to have skipped. But what if Milankovitch cycles didn't exist? Without Milankovitch cycles, Earth would look a lot different. There would have been no ice ages, none at all, which means no glaciers to carve out beautiful inland lakes and valleys. It also means Earth's flora and fauna would have evolved differently. Grasses initially popped up on Earth before the first ice age, but they truly thrived as the Earth became cooler and drier. Grasslands, tundras, and savannas grew all over the Earth, replacing dense forests. With no cooling period leading up to the first ice age, grasses would not have spread so easily. There would be less produce. Dry ice is one of the coldest substances on Earth. This is what it does to a flower. And check out what it does to this action figure. Ouch! Now, what would happen if you swallowed dry ice? What would it do to your skin? How much could you eat before it hurts you? And how would it affect your stomach? This is What If, and here's what would happen if you ate a brick of dry ice. Dry ice is a solid form of carbon dioxide, and it's as cold as minus 78 degrees. And sometimes, people eat this stuff. It's an ingredient that's occasionally used in cocktails and ice creams, but it's only safe in tiny doses. So now, instead of having it mixed with other foods, what would happen if you ate an entire brick of dry ice? But first, how would you get it? Well, you could just buy it, but let's try making some on our own. Dry ice comes from carbon dioxide gas. This gas can be as cold as minus 56 degrees, but for it to become dry ice, it needs to be even colder. And to do that, it needs to be pressurized and cooled. When it's released from the mold back to normal atmospheric pressure, it forms liquid carbon dioxide. And now that we have our liquid, it's injected into a block press, which converts the liquid into a solid. Okay, now we have our dry ice. What happens now? Well, now that you have your brick of dry ice, before you put it in your mouth, you'd first want to touch it. If you were to just poke the dry ice with your finger, it would come back red with a slight prickling sensation to it. That wasn't so bad. Okay, so why not try picking it up with your hands? Well, because after just a few seconds of having the dry ice in your hands, your skin cells would start to freeze and then die. If you kept it in your hands any longer, your skin would begin to turn blue and gray, and eventually you'd lose all sensation in your hands. And now, after learning about how damaging this can be to your body, you're still curious enough to see what would happen if you ate this brick of dry ice? Are you serious? Okay, fine. So, as soon as you ingested the dry ice, you'd immediately feel the same sensation you did on your hand, but in your mouth. Your tongue and mouth tissue would begin to sting and feel incredibly numb. And don't forget about your teeth. You know how bad it feels when you chew ice cream? Yeah, imagine that, but much, much worse. Your entire mouth would be frozen in a matter of seconds, and the longer you kept the dry ice in your mouth, well, it would only get worse. Eventually, you'd lose feeling in your mouth forever. But we're not even close to being finished with the dry ice yet. You'd still need to swallow it. As the dry ice went down your esophagus, you'd feel a little tingling there, and then it would travel down to your stomach. As it's in your stomach, the dry ice would heat up and form gaseous carbon dioxide. This is because as dry ice heats up, it doesn't become a liquid, but rather a gas. Hence the name dry ice. And with this gas in your stomach, you'd start to feel bloated and then a sharp pain. And don't forget about the frostbite on your stomach lining. Luckily, you could burp some of this gas out of you, relieving some of the pressure you'd be feeling. But if you continued to eat dry ice, the pressure from the gas would continue to build. Your stomach would expand and get harder. As the pressure continued, your stomach would rupture. At this point, you'd experience severe pain and vomiting. If you didn't get to the hospital immediately, you'd die. Oh, So please don't try this at home. Let's just keep dry ice to cool party tricks and something you'd occasionally see in your ice cream. Overnight, our planet has gone from a pale blue dot to a glistening white snow globe. Stretches of Earth have become frozen wastelands that are completely inhospitable, and billions of people have been left unprepared for life below freezing. What changes would our planet undergo? What could we do to combat this global freezing? And would humanity be stuck on a giant, irreversible snowball? This is What If, and here's what would happen if the Earth froze overnight. Earth has experienced several ice ages. During these periods, ice sheets pulse outward from the poles and then retract. But 3 of these freezes, between 580 and 750 million years ago, had such an extreme effect that the ice didn't retract for millions of years. These are known as snowball events. Temperatures reached minus 50 degrees Celsius, and the ice and snow reflected light into space. As more heat was reflected rather than absorbed by the planet, the temperature kept dropping. If you could have seen Earth from space back then, it would have looked like a glistening white ball. Eventually, the Earth thawed. Otherwise you wouldn't be here watching this video, but if everything froze back again overnight, could you survive? Okay, let's start by looking at what new kind of planet you'd be stepping onto. Ice sheets 1 kilometer high would cover the Earth. Even in the tropics, the ice would be as thick as 10 meters. Most of the oceans would be covered in ice. Only near the equator or areas with lots of geothermal heat could liquid water still exist near the surface. Everything would be frigid. It would be so cold that most of life on Earth wouldn't be able to survive, especially humans. People living in cold climates would have warm clothing, but this sudden freeze would be life or death for billions. Imagine living somewhere like Belize, Namibia, or parts of Australia where the temperature never drops below 15 degrees Celsius. If you lived in those areas, you'd be at risk of death from exposure to the cold. The same would be true in many other parts of the world, especially for the poor and homeless or those with inadequate access to housing. All power and energy systems would be disrupted, and with no electricity, billions of people wouldn't have heating. Industries would grind to a halt. Even agriculture or livestock cultivation would be nearly impossible. Humans would need to band together to conserve food, energy, and other supplies. You would be ready for living on a giant snowball if you were a scientist based on an Arctic research station. At Amundsen Scott Station in Antarctica, the average temperature is minus 82.8 degrees Celsius. Scientists near the South Pole live in shelters built to withstand the cold and ice. Some even have gyms, greenhouses, a movie room, and a sauna. Life in a shelter, though, would be very confined. You would only go outside for specific tasks. To venture outdoors, you would need layers, a lot of layers. Scientists at these stations wear nearly 9 kilograms of clothing. It takes them about 10 minutes to get dressed. Any exposed skin could be frostbitten in less than 5 minutes. This deep freeze would also make the Earth incredibly dry, as all precipitation would turn to snow or ice. That dry air could make you feel dizzy. you would need to constantly thaw snow for water to drink. And the only way to get around would be with a snowmobile. Or if you're looking for a little recreation, you could try to master kite surfing on snow dunes. But be careful, in Earth's lower latitudes there would be howling winds. This would be another extreme element making life difficult. Researchers still don't know how the Earth thawed from these previous snowball events. Unfortunately, if we wanted to reverse the freeze, we might have to change our thinking about greenhouse gases and global warming. We would need to pump the atmosphere with carbon dioxide and methane. That means releasing pure gas or burning even more fossil fuels. On the other hand, we could use bombs to detonate volcanoes around the world. Volcanic activity is likely what warmed the planet in previous freezes. I hope you've packed some ice skates for your next trip out to sea because the oceans have completely frozen over. What conditions could cause this massive oceanic freeze? How would this impact other parts of the planet? And how could this lead to the mass extinction of life on Earth? This is What If, and here's what would happen if all our oceans froze. Earth has gone through at least 5 major ice ages. The last peaked about 20,000 years ago and made Earth about 5 degrees colder than it is today. But even then, you wouldn't have seen a complete surface freeze of all the Earth's oceans. In this scenario, that's our starting point. A few key factors keep our oceans in a liquid state, except for the coldest parts of the Arctic and Antarctic regions. If these factors were suddenly removed, there would be ice, and lots of it. The first factor is the high concentration of salt. It lowers the freezing point of the water from 0 degrees Celsius to -2 degrees Celsius. Another reason is that there is so much of it. About 71% of Earth's surface is water covered, and about 96.5% of that is salt water. All that volume means an enormous amount of heat would need to be removed to reach freezing temperatures. And don't forget, the oceans are constantly in motion too. Currents distribute warmer waters to colder regions. Lastly, the Earth's crust is the thinnest under the oceans. A lot of geothermal heat escapes from the mantle and up into the water. Without those, I hope you've got sunglasses because the Earth would be a cold but reflective planet. That's because ice and snow have what is known as a high albedo. That's the term for how reflective a surface is. This effect explains how polar ice caps have helped keep Earth's climate stabilized for millennia. Once more than half of the Earth is covered in ice, it would reflect enormous amounts of sunlight. And this would disrupt the planet's water cycle. That heat from sunlight would no longer evaporate water. That would mean no more clouds, and without clouds, no more rain. But don't celebrate by trashing your umbrella. Rain and snow are vital to all life on Earth. Without either, the Earth would become as dry as the South Pole or even parts of the Sahara. The oceans freezing over would likely mean mass extinctions of many species of animals, and since the oceans host 80% of the planet's biodiversity, this would be devastating. But there are thriving marine ecosystems in parts of the Arctic, but those evolved and adapted that way. The rest of marine life would probably perish. And all those dead fish below the icy surface would have a catastrophic impact on the economic stability of humans. The ice would cut off marine transport. That would eliminate 80% of the global trade by volume. Nearly 56 million people working in the fishing or aquaculture industries would suddenly be without jobs. And seafood would no longer be a reliable staple of any diet. No more sushi, poke bowls, or shrimp on the bobby. But all of these consequences would seem pale in comparison to the fact that it would be a lot harder for you to breathe. Yeah, oceans account for between 50 to 85% of the oxygen present in our atmosphere. This is thanks to all those tiny plankton, algae, and bacteria that can photosynthesize. If oceans froze, these would likely die too. And unless you've planted billions of trees overnight, a lot of land animals and people would suffocate to death.
Brain freeze.
If you manage to be one of the very few survivors, well, eventually oxygen levels could normalize again. But I'm not sure what life would look like for you on this frozen planet. From boating to kayaking and whale watching, the ocean gives us joy, and sadly, you would no longer experience the calming effect of looking at the water. You could pick up a fun activity like kite surfing, but with frozen waves, falling would really hurt. I wonder what's worse, the oceans freezing or completely evaporating? Well, that sounds like a topic for another What If.